Hi there, my name is Peyton Mize, and today I'm going to talk about the Lake Pontchartrain Causeway Bridge. Now, please excuse my voice, I am a little sick, however, that will not stop me. Now, this bridge is a marvel, not only because when it was built, it was a revolutionary stepping stone to the structural design of bridges to come after it, but also because I think that it looks gorgeous standing over the open waters of Lake Pontchartrain. I mean, look at it. Simply amazing. Now, in this presentation, I'm going to talk about a few things. First off, I'm going to hit upon the history of the bridge and the circumstances that made the bridge necessary. Then I'm going to discuss both pre-stressed concrete and increased pile size and how both were previously used and used for this bridge. Then I will discuss how the bridge got its own personal factory to custom-produced components of the bridge. So let's get started. So before I talk about the innovations that come with the construction of the bridge, let me first explain a little bit about the lake and why the bridge was needed. The lake itself is 24 miles across and has a mostly clay-based soil. The main reason why the bridge was built was to cut the travel distance to get from one side of the lake to the other in half. And, that's because before the bridge, the only way to get across from one side to the other is to either go around the lake or to take a boat across, which was slow and tedious. The exceptional length would make this bridge the longest bridge over water in the world. And what was more, the engineers only had about 23 months to complete it, which provided them with many reasons to innovate and create. The first innovation caused by the construction of this bridge is pre-stressed concrete. Pre-stressed concrete being when metal bars are tensioned and then they have concrete set around them. Before this bridge, pre-stressed concrete hadn't been used much before, and that's just simply because it was still relatively new. However, this bridge was almost completely pre-stressed concrete, and after this bridge, many engineers adopted pre-stressed concrete for their bridge designs. Why, you might ask? Well, because pre-stressed concrete has a pressure capacity of nearly 10,000 psi, and this is tremendous compared to standard concrete. One of the reasons why this is so important is because the increased pressure capacity allowed the piles to be driven even further into Louisiana clay-based soil that I mentioned earlier. However, that's not the only thing pre-stressed concrete was used for. The next change to the structural design of bridges to be made was the size of the piles, or the supporting pillars. Bridges before this one often had square piles that were at max about 24 by 24 inches, or about 4 square feet. However, this bridge, with the added strength of pre-stressed concrete, had a circular pile that had a diameter of 54 inches, or about 14.75 square feet. These changes were made for three reasons. Number one, the new pile provided more surface area for the bridge to sit on, increasing the bridge's resistance to shifting under a constantly changing load. Two, the increased size of the pile allowed for a greater resistance to strain and stress forces while vehicles drove over them. And three, the increased surface area allowed the pile to bite into the loose soil to be more resistant to shifting with currents in the water. Now, something interesting about this bridge and very few others is that it had its very own personal factory. And this bridge had its own factory mostly due to its very short time frame. This time frame caused the engineers to think about each component of the bridge, the piles, the bank caps, the decks, rethink the whole structure of it. Firstly, these custom components could have been produced in other factories, but these factories are just too far away to be efficient. Secondly, the factory was right on the water, so any components that were produced were able to be put on a barge and sent out to wherever the bridge progress was at the time, decreasing time and increasing effectiveness. And finally, it decreased overall travel time of each component to make the process as efficient as possible. Thank you all so very much for listening to me talk about the Lake Pontchartrain Causeway Bridge and all of its innovations to the structural design of bridges, and I hope that you all appreciate it as much as I do. Here are my references.